All right, so we're going to learn how to add and subtract polynomials, and we will talk about polynomials soon enough, but before we get into adding and subtracting them or learning what they are, we need to make sure that we understand what the phrase like terms means. When I say that we have like terms, what am I talking about? Like terms are terms with the same variables raised to the same powers. Por ejemplo, -c and 4c. They both have the same variable, c, and those variables are raised to the same power, c to the first power. It doesn't matter that one's negative and one's positive. It doesn't matter that the first one has the number 1 for a coefficient and the second one has the number 4. Doesn't matter. The thing that matters is they have the same variable, c, raised to the same power, c to the power of 1. So another example of like terms might be 2/5 f to the 5th g and 3.5 f to the 5th g. One is a fraction and one is a decimal. That's crazy. How could they possibly be like terms? They have the same variables, f and g, and those variables are raised to the same powers. F is raised to the 5th power, g is raised to the 1st power. What if they don't have variables at all? Are those like terms? No. Do they have the same variables? They don't? They both have no variables. Is that the same? Oh, yeah, that is the same. Yeah, I could combine those. I can combine 2 and -1, right? What about 8AP and 7AQ? I have one variable that's the same, but do they have all the same variables? No, they don't. What about if they have the same coefficient, like -6y and -6? Are those like terms? Do they have the same variables? That's exactly right. They don't have the same variables. What about if I have x cubed and -5x? Do they have the same variables? Yeah. Yes. Are they raised to the same powers? No. So we would say this column over here are like terms. And the list that we made over to the right are not. We call those unlike terms. We should call them what? Well, that's pretty much the only kind of jokes I expect from this class. There's one more term that we need to learn besides like terms, one more definition we need before we can add and subtract them, and that is the degree of a polynomial. Doesn't sound fun? Well, let me ask you a question. Do you know how to look at some numbers and find the highest one? Do you know how to look at some numbers and add them together? Oh, well, then you have all the skills you need to find the degree of a polynomial, because the degree of a polynomial is the highest exponent or sum of exponents. It's the little number, yes. The exponent's the little number on any variable term. That's the definition of the degree of a polynomial. So let me give you an example, if you don't mind. So this is what an example of a polynomial addition problem would look like. We're adding two polynomials together. So let's take a look at just the first polynomial. I'll go ahead and highlight it here. This polynomial right there. How many terms does that polynomial have? It has 3 terms. There's a term, there's a term, there's a term. So it has 3 terms. If a polynomial has 3 terms, do you remember what we call that? We learned this last semester. 3 terms is a trinomial. Tri means 3. Now, look at the exponents that we have. We've got an exponent of 3 in the first term. We have an exponent of 2 in the second term. And what's our exponent in the third term? 1, right? So the degree of the polynomial is the highest exponent. What is the highest exponent? 3. So we would say this is a degree 3. Or you could say a 3rd degree trinomial, which is also the highest rank I reached in my math taekwondo class. 3rd degree trinomial. Made my whole body a weapon. Sky's the limit. Third degree trinomial. I'm actually not allowed to fly on airplanes because my body is a lethal weapon. And also because I refuse to fly without my emotional support llama, and American Airlines thinks that's not a real thing. Okay, next polynomial that we're adding. 15 is a term. Negative 4x is a term. Negative 2x squared is a term. How many terms I got? I got 3. Which means the name of this bad boy is trinomial. And let's check out the degree. What's the highest exponent that we have? The first term has an exponent of, Well, there's no variable, so that one has an exponent of 0. For x, the variable has an exponent of 1, and there's an exponent of 2. So this is a degree 2. The highest exponent is 2. So a degree 2 trinomial or a second degree trinomial, which is what I was before I defeated my math sensei in single combat.
Funny.
Rest in peace. Cool. So now that we've identified the name of these terms and the degree of these terms, let's actually do the problem. Let's actually add these together.
I don't know what
Polynomial is just a group of terms. One or more terms makes a polynomial. So a trinomial is a type of polynomial. If we only have one term, like 7x is a monomial. That's the kind of polynomial that you get from too much kissing or sharing a water bottle.
Whoa.
And if you have like 7x minus 3, that is a binomial. Anything that's higher than 3, we just call a polynomial. So if it had like 7 terms, I'm sure some nerd has come up with a name for a 7-term polynomial, but we just call it a polynomial. I wish. It's probably called a septinomial, if I had to guess, because sept is the prefix for 7. Septinomial, octonomial, nonomial, decanomial. Okay. So here's how we're going to add polynomials. And there's a few steps that I want you to write down. To add polynomials. Step 1, rewrite terms that are subtracted as addition of the opposite. Rewrite terms that are subtracted as addition of the opposite. Now, what do I mean by that? I mean, anywhere you see a minus sign, I want you to change that into plus negative. Adding these polynomials is so much easier if everything is addition. So that's going to be step number 1. I'm just going to rewrite the problem. 5x cubed, and then I've got plus 3x squared. And then we have minus x. I'm going to change that minus x to be plus negative x. So that's going to be my first change. Instead of minus x, I'm going to do plus negative x. I'm going to do the same thing with the second trinomial, 15, and then I have minus 4x. I'm going to change that to be plus negative 4x. And then I've got minus 2x. I'm going to change that to plus negative 2x squared. And I'll pause right there to give you a chance to catch up.
That is not a normal call. There's something wrong.
There's not keys. There's something.
Okay. Step number 2. Group like terms.
That's normal call.
Yes.
1x times 4x, so 4x,
4x squared. So group like terms means all of the like terms need to be put next to each other. So our highest exponent that we have is the third power on that 5x cubed. So we're going to write that one first. 5x cubed.
That's cute.
5x cubed to the third power. The next highest exponent we have is squared to the second power. So we're going to write all of the squareds next. So it'll be plus 3x squared plus negative 2x squared. The next highest exponent we have is 1. They're just plain old x's. So plus negative x plus negative 4x. And then we have one just plain old number, which is 15. We'll put that guy on.
Why do we get rid of the parentheses when we group like terms?
We're not getting rid of the parentheses.
So why are we combining them? Oh, we aren't?
We're just putting the parentheses around our like terms now. If you wanted to, we could actually get rid of the parentheses. Since it's an addition problem, the parentheses don't do anything but group them together. So it wouldn't be wrong to write this without the parentheses. I just think the parentheses make it easier.
Make it feel like you have to do it one at a time.
I mean, you do kind of have to do one at a time.
Yeah.
Okay. And so the next step is to actually combine the like terms.
What do we do for the ones that are by themselves?
They don't get to be combined with anything, poor fellas. So for example, our very first term we have, 5x cubed, is the only cubed in the whole problem. So we just do 5x cubed. That's just another way of saying third power.
Oh, I didn't know.
It's three-dimensional object is cubic. Cube is three-dimensional. But then next we can combine the squareds. We have a 3x squared and a negative 2x squared. What is 3x squared and negative 2x squared added together? 3 and a negative 2 gives us 1. 1x squared.
Oh.
3 minus 2 is 1, as far as I know.
Oh, no, I was thinking multiply. My bad.
Use your calculator to check me, but I'm pretty sure 3 minus 2 is 1.
Yeah, no, you're right.
Okay, our next set of parentheses is the x. We have a negative x, which is the same thing as negative 1x, and a negative 4x. So when we combine a negative 1
Negative 5x.
and a negative 4, we get a negative 5x. So it's plus negative 5x. And then our poor 15 on the end, nobody to add with. And that, children, is the answer. There is a fourth step, which is to write the result in standard form, but we already did it. Do you remember what standard form is? Standard form means from highest to lowest exponent. So I would write our answer as 5x cubed plus, you could write 1x squared or just x squared. You could do plus negative 5x, or you could just do minus 5x plus 15. And that's how we do.
Is that it?
That's it for that one. Now that problem was pretty simple in comparison because we only had one variable in there, which was the x. Now granted, the x's had different exponents, which made it a little tricky. But really, we were dealing only with x. Let's take a look at a problem where you have multiple variables in the same problem.
I think I know how to do this.
So here we have two different variables. The variables are p and w, but we have many more terms than that because we have some terms with just p, some terms with just w, some terms with both p and w, and then some terms with not p or w. We will, but that's not the first step. What's the first step? Rewrite. Rewrite the subtraction. Very good. So step number one is going to be to turn all of our subtraction into adding negatives. So minus 2w squared is going to become plus negative 2w squared plus p. And we've got a minus 3pw, which is going to become plus negative 3pw plus 6w squared plus 7. And then group like terms. So the first thing that we have in this problem is the 9p. And it looks like we have another p. There's a 9p and there's a plus.
You're just throwing peas all over the place.
That's what I do. Oh, okay. I'm going to staple this and give it back to you. This is for Hoffman.
Oh, well, here, I'll just take it back up there and just put a sticky note on it.
Well, I need to staple all the groups together. I'll staple them together.
Do you have to?
No. You're right. Why do extra work?
Whatever you can make Lacerda do it.
Okay, next was the negative 2w squared. We're getting there. We're getting there. Negative 2w squared. And we've also got this 6w squared. Shelby's question, she's very worried about this poor guy left out in the cold, the negative 3pw, who doesn't have any like terms. Remember, they have to have the same variables. There's nothing else in this problem that has a p and a w in the same term. So that's just going to be plus negative 3pw all by myself. And then plus 7, same thing, poor fella. Now we combine the like terms and we go one group at a time. Our first group was 9p and p, which gives us a total of, yep, 10. Oh, let me keep my color convention consistent until we get to the answer. 10p. Next set of parentheses has a negative 2w squared and a positive 6w squared. Negative 2 plus 6 is 4. So 4w squared.
A little slow.
And then these two poor guys on the end don't have anything to combine with, so they just stay put. I feel bad for them.
And then we write the result instead.
Standard form from the biggest exponent to the smallest. So the 4w squared comes first. And then it's up to you really whether you want to do PW or P. I'd probably go PW because it's sort of like we're writing it in descending order of W. Then we do the positive 10p and then we do the positive 7. So this is a perfectly acceptable way to write the answer. That's, we're writing it in standard form, biggest exponent to smallest in terms of W. But you could also write it, this will be in descending order by P, which looks a little weirder, but is technically correct. We refer to that as the winger. When you write an answer that looks bizarre, but is technically correct.
Use the wrong formula, but not the right one.
Yeah. You think to yourself, like, what would happen if I did this problem, but like in the dumbest way you can do it? Like, I want to do twice as much work as possible. How can I make that happen? You're like, well, I've got just the thing. I want to do 2 plus 2. Okay, here's what you're going to need. You're going to need some gunpowder in a model rocket.
That's the only way my brain works. So
A slingshot, and 3 gold Sharpies. All right, last thing we're going to learn how to do is how to subtract polynomials. You know how to subtract? Yeah, right. What's 4 minus 2?
Oh my gosh.
You are so fast at subtraction. So fast. Like your answer is wrong, but you got it really quickly. Hmm? What'd you say? Finding the area of a circle is easy as pi r squared. It's 22/7.
Then you would expect, because everybody's expecting a pi joke, but if you don't say pi, then you get everybody like, what is this?
So if you substitute one dessert with another, it becomes funnier.
No, it's because
Finding the area of a circle is easy as chicken wings. My favorite dessert. Oh, I didn't say it right. I said chicken wings and I should have said chicken wings. Okay. So subtracting polynomials followed the same steps as adding polynomials, except we have a little bit of extra subtraction in here, which is that we are subtracting, see this subtraction symbol right here? We're subtracting this entire polynomial. So whenever we do the first step, which is to rewrite subtraction as addition of the opposite, we have to do that entire set of parentheses. So we'll do 7hy squared plus 3h, and then we've got a minus 4y squared, so we'll write that as plus negative 4y squared.
We have to go back at the end and make it all subtraction.
You don't have to, but you can. If you left it as plus negative, that falls into the weird but technically correct category. Now remember that subtraction sign outside the parentheses functions just like the distributive property. We have to subtract every single thing in the parentheses. So minus negative 2h is going to turn into plus 2h. Minus negative 2h.
And
Then we have minus 5hy squared. So that's going to be plus negative 5hy squared. Anytime you have a minus, you change it as adding the opposite. So minus negative 9 is going to be plus positive 9. And that is the trickiest part of all of this, is remembering to subtract everything in that second set of parentheses. Change all subtraction to adding the opposite. So basically what we did was we changed the sign of every single thing in that set of parentheses. The minus 2h became positive 2h, the plus 5hy squared became negative 5hy squared, and the minus 9 became plus 9.
And that's only for that side, right?
Right, right. It's only for the part after the minus sign. Now that we've got that done, it's exactly the same as adding. We're going to group our like terms together. So let's do, here's an hy squared. Anything else in the problem with hy squared?
Yeah.
Yep. This negative 5hy squared. There's our hy squareds together. Next comes the 3h.
Can we minus it and then do it?
You can, yeah. We got a 3h and a 2h. We've got a minus 4y squared. Nothing else in the problem has y squared. So the poor negative 4y squared guy's got to live all by himself. Tragic. And so does 9. Number 9?
9 negative?
It is not. All right, let's combine them. 7hy squared plus negative 5hy squared is 2hy squared. Very good. 3h plus 2h gives us 5h. And everything else stays the same because there's nothing to combine it with. I'm so lonely.
And so can I put minus sign?
Sure. In fact, I would suggest that just to save yourself all the pain and misery of having to write one extra plus sign. Who knows how long that might take? 1, possibly even 1.5 seconds. And I like this for the answer. What Shelby's asking, if you're not following along, is instead of writing plus negative 4y squared, could I write minus 4y squared? And the answer is yes, absolutely. You can and you should. I don't get it, Sierra.
I think she meant to type the question mark, but she forgot to shift it.
It's also perfectly acceptable to write the answer like this. Or if you really wanted to be a weirdo, you could write it in descending order based on y's instead of x's.
It'd be hard to write that in the order of X's.
You're right, h's. Does anyone have any questions for me about adding or subtracting polynomials? Zoomers, any questions about adding or subtracting polynomials?